Let me read the question now. Diagram 8 shows 6 numbered cards. So as you can see here, you have 6 cards. Consists of number 1, 2, 5, 6, 7 and 9. Okay, continue to read the question. Find the number of different ways to arrange all the cards in a row. So this is for the part 1. For the part 2, 4 cards are to be arranged to form a proper fraction such that the even number cards are arranged side by side. Okay, so sorry, the by is left out over here, but it's actually by over here. So side by side. Find the number of different proper fractions that can be formed. Okay, so this is the question A part 2. Okay, let us read the question part B. Okay, question B part 1. The combinations of n objects from m different objects is given by MCN. State the minimum value of n. Okay, so for the question B part 2, Sarah bought a box of colored pencils that contain p number of different colored pencils. Given that the number of different ways for Sarah to choose 3 pencils from the box is 26 times with p minus 2. Find the value of p. So this is the oral question. Okay, so let us begin our discussion for the question 11 part A, and then once we're done with the part A, then we move on to the part B. Okay, because this question personally I felt that it's the trickiest among all. Okay, so let us discuss this part A, shall we? Okay. Okay, so solution. So let me underline. So question A, part 1. Okay, let us start. Okay, so from here the question asks us to find the number of different ways to arrange all the cards in a row. Okay, as you can see, how many cards we have? Okay, let us count one by one. 1, 2, 3, 4, 5, 6. You have 6 number of cards. Do they have any restriction or conditions? There's no conditions. Okay, there's no constraints. Okay guys, okay, if there's no constraint, that means that the number of arrangement will be 6 factorial. Okay, so from here, number of arrangement okay, in this case will be equals to 6 factorial. Okay, 6 factorial is also equals to 6 times with 5 times with 4 times with 3 times with 2 times with 1. Okay, so from here 6 factorial. Okay, let us find the exclamation. Okay, the factorial symbol is over here. 6 shift factorial. Okay, so from here 6 factorial get is 720. Simple as that, guys. Okay, since there's no constraint, it's very straightforward. So 6, okay, and then you add the factorial. Okay, so from here you will find out that 6 number of cards. From there we can form 720 possible arrangement. So from here the number of arrangement is 720. Simple as that. Okay, usually the part 1 they will give without constraint, and for the following part they will give some conditions or constraints. Okay, the second part is the one you need to be careful. Usually the part 1 students will able to do it. Okay, so let us move on to the part 2 now. Okay, 4 cards are to be arranged to form a proper fractions, such that the even number cards are arranged side by side. Find the number of different proper fractions that can be formed. Okay, so for this question B part 2, this is the trick part, guys. Okay, because the question gave us the condition that we need to form a proper fraction. That's one, and then you need to have even numbers to be side by side. Okay, you have 2 conditions here. Okay, listen carefully, guys. Okay, this question A part 2 is personally I felt it's tricky, so please listen carefully. So I'm going to teach you some of the methods that you can apply to solve this question. Okay, so from here, if you come across with this type of questions, okay, my advice to you is try to list down all the possible constraints. Okay, So in this case, the constraint that they tell you is it must be a proper fraction. Okay, proper fraction, that's condition number 1. Condition number 2, even numbers need to be side by side. Okay, even number, okay, just write here side by side. Okay, so these are the conditions that they gave, or constraints, for the particular arrangement to be formed. Okay, so from here let me split this into 2. Okay, so from here they said 4 cards are to be arranged. Okay, so from here, assuming that out of the 6 cards you are taking the 4 cards and you are going to form a proper fraction. So what are the possible proper fractions that you can form? Okay, you can form 2 types of proper fraction. Okay, the first one, okay, as you all know, out of the 4 cards you can form 2 cards as the numerator and then 2 cards as the denominator. Okay, you know what, let me just delete this and draw a square, easier. Oops. Okay, just copy paste this. Okay, so 2 cards as the denominator, 2 cards as the numerator. Okay, this is very straightforward. Probably you will be know very obviously. Okay, of course you have 4 cards and they say the proper fraction. Okay, of course you will put the 2 cards in the numerator and 2 cards in the denominator. That is the one possibility. You have another possibility, which is 1 card will be in the numerator and 3 cards in the denominator, which is possible as well. You can still form a proper fraction in that way as well. Okay, let me just copy this. Okay, and rearrange. One, two, oops. Okay, so these are the possible proper fraction that you can form. Okay, the one over the left, you have a 1 card in the numerator and then 3 cards in the denominator. Okay, that is for the left hand side. For the right hand side, you have 2 cards on the numerator and 2 cards on the denominator. Okay, what I would recommend for the students, you try to solve the left one first. Left one is the easiest. Okay, personally I felt it's easiest, and I recommend you to try in this first, and then once you're done, then only move on to the right side first. Right side is slightly trickier. Okay, it's trickier, guys. Okay, so let me just write here option A. Let me just write here A and B. Okay, so from here let us start with the option A. So from here we need to find the possible arrangement that we can form from the 1 card as a numerator and then 3 cards as the denominator. Okay, so from option A. Okay, so from here we need to come up with some of the cases. Okay, so from here let us start with the case 1. Okay, case 1. Okay, you might have a situation where you have 2 and 6 are side by side. Okay, where you have 2 in the front and 6 in the back, or 6 in the front or 2 in the back, doesn't matter, guys. Okay, so this is easier for us. Okay, why 2 and 6 are side by side? Okay, remember this is the situation where the second constraint applies. Okay, we have already fulfilled the proper fraction. Okay, this is the proper fraction. Okay, and then even numbers are side by side. Okay, among the 6 cards, okay, from here we can find that 2 and 6 are even numbers. Among the 6 cards, we know that 2 and 6 are even numbers, the rest are all odd numbers. So from here we know that they must be arranged side by side. Okay, so that is why I put here 2 and 6 just for example. You can have 6 in front and 2 at the back also. Okay, it doesn't matter. Okay, so from here we need to calculate how many possibility we can have in the remaining 4 cards that we can put in the numerator over here. Okay, so from here, out of the 4 we can choose 1. Okay, we can pick 1. Okay, out of the 4 we pick 1. Okay, so that's why when I tell to my student, okay, 4 P1, okay, 4 pick 1. Okay, out of the 4 you pick 1. Okay, in the numerator over here. So 4 permutate 1, or you can just say 4 pick 1. Okay, 4. Okay, out of the 4 you pick 1. Okay, so this is your first possibilities. Okay, you pick one number and then you put on the numerator over here. Okay, let's say I pick number 1 for example, guys. Okay, let's say if I just pick number 1. Okay, you have 1, 2 and 6. How many numbers you have left over here? Okay, you have number 5, number 7 and number 9. Okay, which you have here 3 numbers. Okay, you have 3 numbers as your options to place over here at the base of the denominator as a third number. Okay, so out of the 3 you pick one more number. Okay, just now out of the 4 you pick one number for the numerator. Okay, and then you multiply with out of the 3 numbers, because why 3? You already picked 1 earlier, so 4 minus with 1, so you only left with 3. So out of the 3 you pick one more number. Okay, and then you times them together. Okay, and remember these 2 and 6 within themselves, they can switch places. Like I said, 2 can be in front or can be back. 6 can be back, can be in front. You can have 2, 6 and 6, 2 within this first 2 block. Possible, right? So that's why you have here 2 factorial. Okay, 2 factorial. So 4 pick 1 times 3 pick 1 times 2 factorial, or 4 permutate 1 times 3 permutate 1 times 2 factorial. Okay, so you calculate this. Okay, 4 shift P1 times 3 P1 times 2 factorial. So from here you get 24. Okay, so this is your case 1. Okay, 24. So let me underline this. So this is your case 1. Okay, we are done with case 1. Let us move on to the case 2. Okay, case 2, there will be a scenario where your even numbers in the second and third box. In the case 1, your even numbers is in the first and second box, right? Case 2, they will be in second and third box. Okay, for example, let's say you have your 2 and 6 over here instead. Okay, case 1 you have 2 and 6 in the first 2 box, right? Now you have the second and the third box over here. Okay, so how do we calculate? Same step. Okay, you have 4 numbers. Out of the 4 number you pick 1 and you place on the numerator. So 4 permutate 1 or 4 pick 1. Okay, out of the 4 you choose 1, you place it over here. Let's say I choose number 5 this time. Okay, you only left with 3 numbers now. Okay, you already placed 1 number over here. Out of the 4 numbers you only left with 1 number. 4 minus 1, 3. Okay, 4 pick 1. Okay, and then times with, you still have 3 numbers left, and out of the 3 numbers you need to pick 1 number and place it over here. Okay, let's say number 7 for example. So 3 pick 1, 3 P1. Okay, and remember these 2 and 6 within themselves, they can permutate each other. You can have your 2 in the middle and 2 at the back as well. Okay, you can have 26 and or 62. Okay, there are possibilities, right? Okay, and that's why you have here times with 2 factorial. Okay, so basically it's just the same case 1 and case 2. So from here you get 24 arrangement from the case 1 and case 2. Okay, so this is from the option A, guys. Okay, option A is very straightforward. Okay, so okay, let me just move these numbers. Okay, all right, so this is from the option A. Okay, once you're done with the option A, let us move on to the option B. Okay, from option B. Okay, option B, like I said, is tricky. You need to be very careful because there are many cases over here, okay, which you need to be extra careful. But don't worry, I will guide you one by one to solve this. Okay, so let us start with the case 1. Okay, and always remember, whenever you solve, you must fulfill 2 conditions. One, it must be a proper fraction and the even numbers must be side by side. Okay, these are the 2 important constraints. Okay, so from here, case 1, there might be a scenario that your 2 even numbers are in denominator. You have here 2, 6. Okay, this time I want to do step by step. Okay, because this option B can be very tricky, so let us do it one by one. So for the 6, 2 in the denominator, we will do it in the different case. Okay, for case 1, we fix that 2 and 6 at the denominator. Okay, so we fix it. Okay, and then let me write the first card as X and the second card as Y. Okay, as a variable. Because you have 4 cards, right? Okay, you can place any numbers within the X and Y. Okay, so from here, let's say you choose number 1 to be placed at X. So let's say you're placing your X, okay, with number 1. Okay, so for Y, how many outcomes that you have, possibilities that you have? Okay, so from here you have your possibilities 5, 7, 9. Okay, you can have 15, you can have 17, and you can have 19. Okay, remember guys, in order to have a proper fraction, your denominator must be bigger than your numerator, which in this case it is fulfilling the condition, and it must be, and the even numbers must be side by side. Okay, so from here, these are the possible cases, and let me write the conditions. Okay, for option B, I don't really recommend you to do this type of calculation, guys, because it can be very tricky, which in this case I'm going to do it manual way, old school way. Okay, so let me write the possible outcomes. Okay, the outcomes, you can have 15 over 26. Okay, and you can have 17 over 26. You can also have 19 over 26. So total you have 3 arrangement. Okay, this is for case 1. Okay, we are done with case 1, guys. Okay, this is the total number that we want, not this. How many arrangement you have? 1, 2, 3. You have 3 arrangement. Okay, case 1 complete. Now we proceed to case 2. Okay, case 2, a similar scenario, but instead of 26, you have 62 in the denominator. Okay, you have here 62. Okay, so from here, always remember we need to fulfill a proper fraction. So from here, what are the possible x value that we can form? Okay, you have 1, 5, 7, 9, right? Okay, so from here you can have your possible x value to be 1 possible. You can also have your possible x value as a 5 possible too. Okay, 5 if you place here still smaller than 62, right? Okay, regardless of any value comes at y. Okay, so let us, within this case too, we are dividing into two options. Okay, assuming that your x is equals to 1, so from the y you have here 5, 7, 9. Okay, so this is for the, okay, let me just write here option 1, this is the option 2. Okay, you have your x 5. Okay, when you have x equals to 5, so from here your y will be 1, 7, 9. Okay, so from here the outcomes, so let me write the outcomes over here. You can have 15 over 62, you can have 17 over 62, okay, and then you can have 19 over 62. These are the outcomes. Okay, for the option 2, you can have 51 over 62, you can have 57 over 62, and you can have 59 over 62. Okay, so how many total outcomes within case 2? 1, 2, 3, 4, 5, 6. So you have a total of 6 outcomes. Okay, later on these outcomes from option B and option A, okay, and from option A we're going to sum them up all together, guys. Okay, so please stay with me. Okay, we done within the option B, we done with case 2. Let us move on to case 3. Okay, so now we can have a possible arrangement where your even numbers are arranged side by side in numerator now. Instead of denominator, now they arrange in numerator. Okay, so let me just copy paste this over here. Okay, delete 26. Okay, so this is the case 3, even number side by side. For instance, you have 26 over here, so this is the case 3. Okay, now what are the possible x values that we can form? If you say 1, your answer is totally wrong. Why? If you put here 1, it will be improper fraction. Okay, always remember, you must go back to the conditions apply. Okay, you must have a proper fraction, and then even numbers must be side by side. For proper fraction, your denominator must be bigger than the numerator. What does that means? Your x value must be at least be equal to 2 and bigger. Okay, in this case you don't have 2. Okay, so it must be bigger than 2 in this case. So the minimum, the smallest value that you can possibly have is 5. Okay, so from here the possible x value that you can have here, okay, for the first possible values of x you can have here is 5. Okay, if you have x equals to 5, okay, the y will be 1, 7, 9. Okay, the next possibilities, you can have your x value equals to 7. Okay, if you have your x value equals to 7, you have y equals to 1, 5, 9. Option 2, you can have your x value equals to 9. Okay, still fulfilling the proper fraction properties. So from here your y value, possible y values will be 1, 5, 7. Okay, excuse me. So let me write all the possible outcomes over here. So from here you can have 26 over 51, 26 over 57, 26 over 59. Okay, 59. Okay, and then followed by 26 over 71, 26 over 75, 26 over 79. Okay, and then continue with the third option, 26 over 91, 26 over 95, 26 over 97. This is your case 3. Okay, how many possibilities you have? You have here 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 arrangements. Okay, so we're done with case 3, option B. Okay, so let us move on to the final case, case 4. Okay, for the final case, you have here even numbers side by side, but in this case it is 62. Okay, so it's slightly different. Okay, always remember our x value must be at higher than 6. Okay, so from here your possible x value that you can form over here and the denominator is 7 and 9. Okay, let us start with 7. So when your x is equal to 7, the possible y value that you can form is 1, 5, 9. Okay, second option, you can have x is equals to 9. Okay, where your y is equals to 1, 5 and 7. Of course, you cannot have 1 and 5 at the x position here, guys. Okay, we need to form a proper fraction, so that is the reason. Okay, so let me write the total outcomes. So it will be 62 over 71, 62 over 75, 62 over 79. Okay, so 6, guys. Okay, so from here the next outcome, it will be 62 over 91. Okay, 62 over 95 and then 62 over 97. Okay, so how many outcomes you have in total? 1, 2, 3, 4, 5, 6. You have total of 6 arrangements. Okay, so now what you do, you need to sum them all the cases from option A until option B, all the 4 cases as well. You sum them all. Okay, so from here 24 plus with 24 plus with 3 plus with 6 plus with 9 and then you plus with 6. Okay, let me write down here. So 24 plus with 24 plus with 3 plus with 6 plus with 9 plus with 6. Okay, so let us solve them together. 24 you get is 48. 48 plus 3 is 51, 51 plus 6 is 57, 57 plus 9 is 66, 66 plus 6 is 72. So from here you get a total of 72 arrangement. So this is your final answer, 72 arrangements. Okay, so we are done with the question 11 part A. So let us move on with the question 11 part B. Okay, question 11 part A is more towards the permutations. Okay, whereas question 11 part B is more towards the combinations. Okay, so what is the difference? Okay, they're just a differentiation of the emphasizing of the arrangement. For permutation they are emphasizing the arrangement, whereas for combination they don't emphasize the arrangement. Okay, question B, part 1. Okay, let us take a look at the part 1 once again. Okay, the combination of n object from m different object is given by MCN. State the minimum value of n. Okay, so what are the possible value of n you can actually form? The minimum value, guys. Okay, the minimum value of n. Okay, this one you don't need very sophisticated working. Okay, you can just straight away write your answer, n is equals to 0. Out of the number of trials, you can have 0 possible arrangement. Out of the 5, you have 5 objects, you can choose none of them. Okay, out of the 5 objects you have in your front of you, you can choose none of them. Okay, that's why you can have the minimum of n is equals to 0. Okay, so this is the question B part 1. Okay, you can have an option to choose none of them. Okay, so that is the explanation behind for the question B part 1. Okay, for the question B part 2, okay, Sarah bought a box of colored pencil that contains p number of different colored pencils. Given that the number of different ways for Sarah to choose 3 pencils from the box is 26 in a bracket p minus 2, find the value of p. Okay, so we don't know how much of color pencils that she had literally have. Okay, but then we can form the possible workings. Okay, assuming that out of the p color pencils that she have, she choose 3 of them. Okay, and from here she got 26 in a bracket p minus 2 possible combinations of the color pencils. Okay, so from this, within this combination of expression, we need to convert them into equation. So let us convert them into equation. So from here, p factorial, okay, divide with, excuse me, okay, from here p factorial, okay, divide with p minus 3 factorial, okay, and then times with 3 factorial. Okay, and then from here you get is equals to 26 in a bracket p minus 2. So these are the formula for combinations. Okay, so let me just erase over here. Okay, so let us calculate this. Oh, forgot to change into pen mode. Okay, so let me proceed. So 3 factorial you calculate, it will be 3 times 2 times 1. So in this case it will be 6. So p factorial, okay, divide with p minus 3 factorial, okay, and then times with 6. So from here you get is equals to 26 times with p minus 2. Okay, so this p factorial we can break into equation, where in this case we can have p times with p minus 1, and then p minus 2, and then p minus 3, and so on and so on. Okay, so at a certain point of arrangement, I mean our equation, so we can do some of the cancellation from here. So what we do, we choose the lowest one, p minus 3, and then we make it such that the p factorial in the expression of p times with p minus 1, and then times with p minus 2, and then times with p minus 3. Okay, so let me do it one by one. So this p factorial, we're going to follow exactly in the denominator. So from here we break down into equation. So p times with p minus 1 factorial times with p minus 2, I mean in terms of equation guys, okay, times with p minus 3, okay, divide with p minus 3 times with 6. Okay, this factorial symbol we can move them away. Okay, 26 times with p minus 2. So from here the p minus 3 and p minus 3 we can cancel them out. 6, since you have the p minus 2 in the left hand side and the right hand side, they both also can cancel them out, can be cancelled. Okay, so you only left with p in the bracket p minus 1 equals to 26. Okay, p in the bracket p minus 1 equals to 26. Okay, so we can form actually a quadratic equation. So from here, expand the bracket. So from here, p square minus p, okay, minus 26 equals to 0. So let us perform the factorization. But before that, yes, I've made a blunder mistake. Guess where? The 6 here, you should be timesing here, guys. Okay, p in the bracket, p minus 1 is equals to 26. Okay, the 6 in the denominator, you times at the 26 over here. 26 times is 6. So from here, p square minus p is equals to 156. Okay, if you're not confident, 26 times it's 6. So from here, get is 156. Okay, so from here, p square minus p minus 156 is equal to 0. Okay, from there we perform the factorization. So from here you get is p minus 13 times with p plus 12 equals to 0. Okay, you can have only a positive value, which in this case p equals to 13. You can have 13 color pencils, not negative 12 color pencils, right? Okay, so 13 will be your correct answer. So in this case, p is equals to 13 color pencils. Okay, so let me scroll this up. Okay, we have come to the end of our discussion for the SPM 2021 Paper 1 Question 11. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.